All right, here we go. Section 5 and Chapter 7. You will be very excited because this is not going to take that long. So that was a little mess up there. Maybe I'll quiz you guys on that later. So we have Section 5 is super easy. I think it is, but there are properties that you need to remember, and unfortunately that's not always our strong point, but just follow along. Remember, we talked about how logarithms are the same as exponents. They're the inverse of exponents, but they're dealing with exponents. A logarithm is an exponent. So therefore, when you see these properties, they should be a little bit familiar. So here, what we have is we have our product property. So what it means is when we're taking the logarithm of our multiplication, so it's a logarithm of a product, it's the same as exponents. When we are multiplying exponents, we end up adding them. So this is going to be log base b of m plus log base b of n. So whenever you're multiplying two, logarithm of a product of something, you're going to basically be adding both of them, the logarithm of m plus the logarithm of n. With a quotient, exactly what you'd expect, you're going to subtract. It would be the logarithm of the top minus the logarithm of the bottom, which is n. And the last one, it's a power to a power. So remember, the logarithm of m is a power already, and then we're going to raise it to another power. So that property was multiplication. So what we're going to do is, it's real simple. You take this power and you just move it out front because that will multiply. So it'll be n times the logarithm base whatever, in this case b, of m. So n times the logarithm of m. Okay, real simple. So now we're going to go through a few examples here to illustrate how this can be used. And again, this isn't really hugely important now that we're in the day and age of calculators and things like that. But let's go through these. So basically what we're given here in these examples is we're given a couple of, they're basically telling us what the logarithm base 5 of 4 is. And they're giving us what the logarithm of base 5 of 9 is. So what we're going to do is we're going to use these two to evaluate some of these. So here we have, let's just start with something easy. We have the log base 5 of 4 over 9. Well, the property is just to subtract these. So that's what we're going to do. So what's going to happen is we know what the log of base 5 of 4 is. It's 0.861. And then we're going to subtract what the log base 5 of 9 is, which is 1.365. That should be fairly simple, straightforward. Subtract that in a calculator, and we get negative 0.504. Now, for this one, this is a little bit different. But again, this is what you need to be thinking about. Based on what's given you, you're given a 4, you're given a 9. So when they start asking you things like 36, think about how 4 and 9, how you can make 4 or 9 or both of them turn into 36. Well, that's real simple. 36 can be written as 4 times 9. So therefore, we can write it as log base 5 of 4 times 9, which is the same thing as saying log base 5 of 4 plus log base 5 of 9. So therefore, we have 0.861 plus 1.365. And that is equal to, add those up, and we get 2.226. Okay? And then this last one, we have 81. Well, again, think about 4 or think about 9, and think about how we can get to 81 with either of those. Okay? You could say 9 times 9 maybe. Or you could even say 9 squared. So I'm going to do 9 squared in this case so you can see a different example. So 81 is the same as 9 squared. So that's how we will write this. But now we're going to rewrite, we're going to use our properties. So this will be 2 times log base 5 of 9. All we did was bring the 2 out front. That's what our property says. So therefore we have 2 times, and our log 9 is 1.365. So you multiply those two together and you get 2.73. Okay, so that's just kind of using our properties to our advantage here. So what I want you to do is do these three on your own. Okay, I'm going to pause it in 5 seconds, and then When you're ready, hit play just to see if you have the right answers or not. Okay, so hopefully those were pretty easy for you. The solutions are written for you here. We had log base 3 of 6. We turned that into 12 divided by 2, which gave us a subtraction problem, 1.631. Second one, we had 24. We turned that into 12 times 2, so that was an addition problem, and we got 2.893. And then the last one, which was a little bit trickier, we turned into an exponential one. We had log base 3 of 2 to the 5th. So we had 5 times log base 3 of 2. So 5 times 0.631 equals 3.155. Okay, so hopefully those made sense. Okay, so now let's get into something a little bit different. Same idea though, we're going to use our properties here. So we're going to rewrite these expressions. So what we mean by expand is we want to use our properties to write these out. So that's exactly what we're going to do. Now, what I'm going to do is I'm going to do this step by step. You can do it, quicker if you want to, but just make sure that you're not skipping anything. So what I'm going to do is I'm first going to just separate the top and the bottom. So this will be log base 6 of 5x to the third minus log base 6 of y. Okay, that's our first step. The problem is that this can still be expanded. Okay, that is not completely expanded. Not only do we have an exponent on the x, but we also have 5 times x. So next step will be log, and I'm going to say log base 6 of 5 plus log base 6 of x to the third minus log base 6 of y. And again, we're still not done because this 3 is here. Now, you guys can skip these steps. I'm okay with that. But I'm just showing you the longest way possible. So this will be log base 6 of 5 plus. This 3 will come out front, so it'll be 3 log base 6 of x minus log base 6 of y. And then that is our final solution. Okay, so that's how you expand. Now when we're condensing, we're going in the opposite direction. So the condensing, I think, is a little bit easier, but you see, okay, this 3 out front will be an exponent, so we can bring this 3 to the exponent. The 9 plus will be multiplication, and the minus will be division. So I write this like this, log, and then in parentheses, on top, I'm going to have 9 times 2 to the third, because 2 to the third power, and on the bottom, because of the subtraction, we're going to have 3. Now we simplify. 2 to the third power is 8. 9 times 8 is 72. So this will be log of 72 divided by 3. And then you can actually do 72 divided by 3, and we get log of 24. And that's how you condense that. Okay, so on the next page, I want you to do these on your own on top. Okay, and again, I'm going to pause it in about 5 seconds. When you're ready to check your answers, hit play. Okay, so we're back. Now, the one thing I want to show you on this one right here, here's the big mistake that people will make. So we had log of 3 plus 4 log of x. That's the top portion. The bottom portion is log of 4 plus 2 log of y. The difference is because we're subtracting this entire thing, we have to put this in parentheses. So if you don't have this minus right here, if you forgot your parentheses, then it's wrong. You can't just have minus log of 4 and then plus 2 log of y unless you have this in parentheses. And then, of course, that subtraction sign would go to both terms. So very important there. The other one, real straightforward. This ended up being 4x times 3 to the third power. This 3 came up to the power. Multiplied, that was 108x, divided by 12, ln of 9x. Okay, the last thing we have to do is, I'm just going to show you this briefly. You do not have to do this in class. But the reason why I'm going to show you this is because not all of you have graphing calculators at home. So what we're going to do is, basically what a change of base formula is if you look on your calculator, basically, especially a scientific calculator, almost all of them just show you this. Or they just show you this, which means the only 2 buttons that they really have is base 10 or base E. So if you're given something that's not base 10 or base E, back in the day when we didn't have graphing calculators to do this for us, we could do a change of base, and it's real simple. The change of base is simply, we're going to take the 8 So this would end up being a change of base would be log base 10 of 8 divided by log of 8 divided by the log of 5. That would give you, putting that into your calculator, if you only have a scientific one at home, will give you exactly what log base 5 of 8 is. Also, you could do ln. ln of 8 over ln of 5. Either one of these will work, and a scientific calculator, not a graphing calculator, can actually do these. The graphing calculators can actually do the bases. So when you're in class, you can just evaluate at log base 5 of 8. But this is an appropriate way of doing that. And if you put this in, you would get 1.292, and you would get 1.292. And if you had a graphing calculator, you would get 1.292. Real simple process. Maybe not the easiest thing to remember because you don't use it very often, but that's what it is. So that's all we have from section 5. I hope that was short and easy. Don't forget to take your quiz on Edmodo.